Hello, everyone, and welcome to Cisco Unplugged. My name is Dan Clamert, leader of the Wireless Center of Excellence here at Cisco. And this week in episode 28, we're going to be discussing 9800 wireless LAN controller serviceability. And thanks again for tuning in. It's hard to believe we've been doing this almost for about a year now with Unplugged. So we appreciate you and your viewership. So thank you for tuning in once again. So on today's show, I'd like to welcome our two special guests today. Welcome them back to the show, actually. So welcome Benny Chong from New Jersey. How are you doing, Benny?
Great, Dan. Good morning.
Yeah, great to have you back. Thanks. And also Mr. Dan Davis from New Hampshire. How are you doing, Dan? Good to see you again.
Hi, Dan. Good to be here, especially for the anniversary session.
Yeah, thank you very much. So before we get going here and kick it off, just want to remind people if you would like to tune in and see, I guess, future episodes as far as what we've got planned, you can go to cs.co/get unplugged and see what we've got on the docket coming. Also, you can go to our YouTube channel, youtube.com/@get unplugged. And I'd encourage you to subscribe there. You'll be notified when we do go live and post more great content. So before we get going, we also use Slido for questions. So if you're on the WebEx, you'll see that Slido panel on the right-hand side. If you are on our YouTube channel, you see the link below to join the Slido. Click that, join the Slido, and you can submit your questions. I usually will pop a couple of those questions, interject those live during the episode. So with that, I want to again thank you for attending and watching today, and I will now turn it over to Benny on with the show. Take it away.
Great. Thanks, Dan. So, good morning, everybody. So, Dan, you have the dictionary definition of serviceability there up on your slide. What are we going to cover today as far as serviceability on the C9800?
Well, Benny, serviceability means a lot of different things. I think for some people, it might start off quite simply as a console cable. For other people, it's much more than that. And we think that our product, the 9800, which is the focus today, offers quite a bit in terms of serviceability. So we're going to go through some of the basics, starting with syslog and get into some more of the capabilities that are a little bit, it's not as traditional. Binary tracing or always on tracing and RA tracing, embedded packet captures. And at the end, we're going to talk a little bit about what you can do if none of the above have really helped you, get to the root cause of your problem.
Yeah, Dan, I have my console cable right here. Never leave home without it. It's my go-to when, especially when I have to connect it to an access point.
Yeah, and of course, we also have console connections on the wireless LAN controllers. But Benny, that's just the start of it. We actually have some other features too, like binary tracing that we're going to get into. But let me say that, some customers, when it comes to serviceability, they prefer just to make a phone call into an organization like TAC and, wait for them to return the call and then collect the necessary data. But it depends. Some customers are a little bit different. They've got, I'll say, more technical talent. They've got maybe more time on their hands. They might actually be, say, focused on the wireless product. Some smaller companies, a lot of times the network IT people are kind of the jack of all trades. They're doing security, they're doing data center, they're doing wireless. They want to just pick up the phone and call. But we've got other customers where they're willing and ready to roll up their sleeves and do some troubleshooting. And a lot of times we find that they can solve a lot of the layer one or level one or level two issues pretty quickly.
Yeah, so it sounds like with the C9800 controller racked in my data center, I can at least do some preliminary troubleshooting um, on an issue I might be having.
Yeah, definitely. Yeah. So, I mean, you can reduce downtime if you're working in, say, healthcare, as an example. Maybe you've got some carts on wheels. These are used for collecting medical information. If you're having some problems with those and you want to do some basic client connectivity troubleshooting, absolutely, that's serviceability. Maybe you're in a distribution center. A lot of times, I've seen customers even most recently where They've got brand new fork truck data collection terminals. Everything was tested. They went about the process pretty religiously, but when it came to production, they ran into some problems. And some of the capabilities we're going to go over today would help them really narrow that down and solve it pretty quickly.
Yeah, so I have my console cable. I get it. So tell me a little bit more about syslog, right?
Yeah, so this starts off with syslog, and syslog is nothing new. In fact, we're calling this iOS D logging. And the previous operating system before iOS XE, which is what we ran on the 9800, was called iOS. And we've taken that syslog capability from that operating system and turned it into a daemon that runs on iOS XE. So it's called iOS D, D for daemon logging. And this is a really good place to start. For instance, if you have some issues with APs not connecting to the controller, you can see there's an example there. Or maybe it's client connectivity, using a pre-shared key. The client's not joining. A lot of times it's a key that wasn't entered in correctly. And, we have the syslogs that are generated on the controller, and you can see those from the GUI, but they can also be sent out to a remote syslog server. So you get some historical data there. And on the APs as well. And I got to say, most customers I work with don't turn syslogs on the AP, but it's probably a good idea to do so and to have those sent externally. And on the 9800, if you look at like the AP join profile, it gives you the ability to put in an IP address for a syslog server that's out on the network collecting syslogs from all the different products.
Yeah, it's kind of a shame, Dan. I think a lot of customers actually don't collect syslog from the access point. That's pretty powerful.
Yeah, it can be. And it's a good place to start. But it's a lot more than that. Serviceability, I'd say this is the start, and this is traditional or more historical capabilities. But where we really, I think, start to shine on the 9800 platform is what's called binary or B trace. Uh, Also, people will refer to this as always on tracing. And it's unique because, well, it is always on. These traces are running continuously. If you've got a 9800 in production right now, it is collecting always on traces. And these traces they're written to memory first, and then they are written to a file. And we're doing this in binary. So it's not something that you can read without having the decoder on the 9800 present it to you in a readable format. And the binary text or the binary format allows us to have traces that are always running. And we're also compressing them. And, we're collecting this data at, it's called the notice level. It's not a real super granular level. And you can kind of see an example here. This is a client going through what we call the client state machine. You can see at the top it associates and then it authenticates. You got 802.1x, DHCP. And then you kind of reach this holy grail state at the bottom called the run state. But it's very easy to kind of follow this through when we're collecting data at this notice level. It's not super granular. So you can run commands and then pull data out from whatever time frame you like. And you can also put in different filters as well.
I think the key there, Dan, it's always on. It's always running or tracing at the notice level. So if something goes awry and by the time the user of that client device opens a ticket and ticket gets picked up by the help desk, it could be some time. It could be an hour or so. Or what if I take Friday off, right? And I don't on Monday I come back.
Yeah.
I want to find out what happened, right? So you're telling me I
Yeah.
can go back in the logs and find out exactly what happened.
Yeah. It's time travel. Uh, you take a lot of Fridays off too, don't you? I mean, do you ever work Fridays anymore? Just
Dan, we don't have to talk about it on here.
good.
Move on, please.
All right. Well, Benny, so yeah, that's a perfect example. here's the commands. And I don't want to spend too much time on this. By default, I'll point out that these commands log data from the last 10 minutes, but we can go back much farther than that. If you're taking Fridays off, yeah, we got you covered. In fact, if you say did take a Friday off, and maybe Friday when you were at the beach, things went sideways on wireless, come back in Monday morning, and what you can do is run, one of these commands that I've shown, and maybe you're gonna put a filter in it, like an IP address or a MAC address, and you can also put a timestamp in it and say, I'd like to understand what happened on Friday afternoon between 2 o'clock and 4 o'clock with this particular client.
What if
Right?
there were,
Mhm.
sorry, Dan, what if there were several clients that had the issue? Can I filter on multiple client MAC addresses?
You can. You can absolutely do that. And you can actually go back in time for. We find that sometimes it's over a week, and it really depends. Like, mileage will vary, right? So if you've got a controller that's fully loaded with access points and controllers that have lots of clients on them, then you can't collect as much data. But we've designed it on, for instance, the 9880 platform to at least be able to capture, 48 hours, so we got your long weekend covered.
Thanks, Dan. So I liked the syslog. I like that btrace is always running, and looks like both of these are got to from the CLI. Is there anything on the 9800 web UI or the GUI that I have access to that gives me to address similar scenarios?
Absolutely, Benny. And it's almost like we rehearsed this. So we have what's called RA, or radioactive tracing. And as you can see, this is initiated from the GUI.
Wait, radioactive? Like
Yeah.
when they injected me with that radioactive tracing liquid and traced what it how it's flowing through my body?
Yeah, yeah, we've borrowed a little terminology from the medical community, but yeah,
Got
that's
it.
the analogy, Benny. Uh, and the way this works is if you're maybe at the GUI from the monitor perspective, you'll see the clients you're monitoring, you'll see the APs you're monitoring, and there's a little icon next to each of those, and you can click on those icons, and it will bring in the MAC address of whatever icon or whatever client or AP you select, and it'll bring it right into this field that we're showing here. And you can also enter in multiple MAC addresses, and the way this works is it's really kind of built on top of the foundation of binary trace, but it's a little bit different. RA trace, what it does is it takes a particular MAC address, and then it runs that MAC address through any process on the 9800 that MAC address touches. Okay, and let me give you an example of some processes. So radio resource management, this is how the APs dynamically set up their powers and their channels. That's a process. Another process on the 9800 might be the rogue process. This is how the controller identifies rogue APs. So when you enter in these MAC addresses into the list, or maybe it's a single MAC, it's going to go into each of those processes that the MAC address hits, and it's going to turn on a higher level of debugging. It's called the debug level, and it's more verbose and more informational than, say, the btrace level. But that's good if you're trying to find a needle in the haystack. It gives you the capability to do that. And the way this works is a little bit different. So you're going to enter in your MAC addresses, and then you're going to go ahead and hit start. And again, go recreate the problem. Have the client do the roam. Have the AP try to join. And then what you can do, see the green button there? It says generate. Well, what that does is that will then take those binary traces that have been collected on the controller, and for maybe the last 10 minutes, maybe it's the last 30 minutes, maybe it's the last hour, it will then pull those out, allow you to easily download them. It'll decode them so you can, you don't have to read the binary file, and then you can easily view them.
And I think also on the client monitoring page, where you're looking at the list of clients joined to your AP, your deployed APs, there's actually, I think, a fast link um, from that page to here to run your radioactive trace.
Yeah, we're trying to make it easy. And if you're looking at a client just to see if it's connected, you might start off on the monitor page. And if you want to do a trace and dive in a little bit deeper, then yeah, it's a URL that just directs you to this radioactive tracing page.
Makes sense.
Hey, Dan and Benny.
Yep.
If I could just interject here quick, it's great. So we've got a bunch of questions actually, and on this topic that we're discussing here around B trace, radioactive tracing. One of the questions was around with B trace running all the time, should I be concerned about the impact to memory on the WLC? I have a hard time today currently managing WNCDs. There's a couple others about performance concerns related to also the radioactive tracing. Is that client impacting? Can I have, well, clients are connected. Can I do this? And then I think you touched on it a little bit, Dan, too, the difference between RA trace and B trace. Sorry to lob all that at you, but so I guess could you address any, I guess, performance related concerns or questions with the B trace and RA trace, and then
Sure.
Yeah,
also
and
just
I
kind of
don't
the
want
differences.
I don't want to be bringing down the production environment if I run the RA trace during production, right?
Right. Yeah, understood. And certainly a valid concern. And I appreciate the questions too. So the with the binary trace, it was designed so that those traces are running all the time. And if you would like to use the CLI commands to um, convert the binary data into, I'll say, human readable data, you can do that for multiple clients. There's no performance impact. With the RA tracing, like I said, you can have a list of MAC addresses or IP addresses. And if you're doing RA tracing on, say, 4 or 5, even 8 clients, that's not a problem. If you're going to try to do it on, say, 20 clients and you've got a very busy box, fully loaded up with APs and clients, uh, yeah, I would caution against that. Maybe take a step back and do a couple clients at a time. And the big difference between binary trace and radioactive trace is the binary trace is done at the notice level. Okay, it's not as granular as a trace as the radioactive trace. Radioactive trace is done at a more detailed debug level, and it can also be initiated from the CLI. And another way people are using radioactive trace is if you've got one particular client, maybe it's say your CIO's got a Teams meeting or a WebEx meeting on his laptop and it intermittently drops, just as a scenario. You could, go into the RA trace and enter in his MAC address and let it run all day.
Mm.
That's the way we designed it. And then if he sees a failure, you could go back and say, oh, okay, I know 10 minutes ago he reported the issue. So I'm going to say, pull up the data from the last 10 minutes or maybe 30 minutes.
So Dan, that's a good point, right? If you let it run all day, it's going to collect a ton of data, especially at the debug level. What is there some way to find that needle in a haystack?
Yeah. So notice there's a little URL at the top,
Yeah, I
wireless
was going to ask
debug
you about that
analyzer.
one.
Yeah. That's there because these are debug level traces and they're pretty verbose. It's not that you can't understand them, but we've given you a tool set to make it easier. Okay. So this is a tool called the Wireless Debug Analyzer. It's one of many tools that are out on the Cisco DevNet page. So if you were to say Google this, you would say search Cisco uh, developer network and then wireless debug analyzer, and I'm sure you'd find it. But you can take an RA trace, easily exported from the 9800. And by easily, I mean there's no like SFTP component there. You can just download it to your desktop and take that file and drop it into the wireless debug analyzer. And it gives you nice graphical images for stuff like, why was my client all of a sudden deleted? Or why did the client struggle with the onboarding process? What about roaming? Right. So it's a very helpful tool that kind of brings those collected traces at a higher level, allowing you to tackle those, tier one and tier two problems without making the call to the help desk, or, well, not the help desk, but to TAC.
Looks like you have the link posted up here, Dan, on the slide. So that's where you would upload the RA trace file.
Yeah. Yep. It's pretty easy. It's a point, click, and drop it in, and then, review the data that it shares with you.
Yeah, and the tool actually converts the ton of data that you collect to something more meaningful at a high level, and then you can dig in deeper where your interests.
Yeah. And these tools were written by, escalation engineers that kind of sit on the top of the tech folks. So great functionality.
All right. Well, so this you talked about btrace, you talked about syslog, you've talked about radioactive tracing. I've worked with TAC in the past, and one TAC engineer told me about or talked to me about EPC, or embedded packet capture. What's that all about? And maybe you can jump into that.
Yeah. So this is another area where you can get packet captures. And this I kind of highlight as, the ability to get a data plane packet capture. And when we internally talk about products like this, we'll often say control plane or data plane. So the control plane is simply traffic that's going, say, to the CPU. So if you've got a client that's going through the connection process, that's a state machine, and the CPU is involved in that. If you're doing something with guest access and you've got a captive portal, the CPU is going to get involved in that as well. Uh, Data plane traffic, on the other hand, is when the client has gone through the state machine and it gets to that end process, the run process, and now you're just quickly passing data through the appliance, right? So that's the data plane. Just want to call out that difference there. But this particular tool here can be used as a great alternative to collecting packet captures without having to do the traditional, say, span port of the uplink connected switch. Okay, and it's also got some filtering capabilities. Now, the filter here is just showing any, but you could go and create like an ACL through the GUI on the controller, and maybe that ACL would say, permit IP address of an access point, and you could select that as the filter. So now you're collecting a packet capture for just a single AP. So it's got some nice filtering capabilities there. You can choose to monitor the control plane if you want, and that's just a simple checkbox. And that's, again, all the data going to the CPU, or you can leave that unchecked and just look at the data plane. And there's a couple other things. Go ahead, Benny.
I was just going to ask you, what's that field for inner filter MAC?
Yeah, so there's two of them, right? Inner filter MAC and then interfilter protocol. So the interfilter protocol is a checkbox just to help you troubleshoot DHCP. If you've got a client that is having some problems getting an IP address, you can enable that. And what it does is there's a CapWeb tunnel going from the AP to the controller. And, it's going to use a source address of the AP and a destination address of the controller. And those would be considered kind of the outer addresses, right, of this CapWeb tunnel. The term inner refers to what's carried inside that CapWeb tunnel, and that would be something like your client IP address. If you're troubleshooting a client joining and there's DHCP issues, well, inner filter protocol checkbox would, filter for you on that. Or you could put in the inner filter MAC of the client. And if you just wanted to see traffic that was inside that CapWeb tunnel, that would do the same thing.
Is 10 meg the max buffer size?
10 meg is pretty small. We can go to 100. However, we've enhanced that. In 1712, we can now go to 500. And then we also have kind of a rolling buffer on 1712 too. If you're using something, if you're using code version less than 1712, maybe if you're on 17.9 or 17.6, it's something to be aware of. If you do capture the problem, maybe you're doing some troubleshooting for an AP or a client, it's a good idea to, stop the embedded packet captures once you've collected your data. You don't want to let it continue to run because you might overflow the buffer. So yeah, it's something to be aware of. But we've enhanced it so we can collect a lot more data now.
That's
Hey,
great.
Dan, while
Thanks.
we're on the topic here of the EPCs here, there are two questions on this topic, and I think you just answered one, but how big of a file can I capture with EBC? And then will EPC keep all the CapWap tunnel data?
Yeah, so you can capture, like I said, it's just a review. It's 100 meg
Yeah,
on the versions that are earlier than 1712, and you do have to be careful, especially if you're troubleshooting like client connectivity issues with certificates. APs
sure.
also use certificates, right? A lot of data when you get into the TLS piece.
Yeah.
Yeah, so that's something to be aware of. And then, yeah, it will also capture CapWeb traffic information as well. You should be able to visualize that. It's a PCAP, so you can, pull it up into something like Wireshark.
Yeah.
And you can also select the interface that you want to capture on. You do not have to, but it's very easily to do that from the GUI.
Sure.
And notice that there's a VLAN 1 interface here. There's also a Gigabit 1 interface. Uh, it's best typically to select, say, the Gigabit Ethernet 1. And the reason being is the VLAN 1 interface is an SVI. So if you're doing something where there's some layer 3 routing going on within the box, then that'll certainly show up on the SVI. If you set up that SVI to be the source of the traffic, maybe it's radius traffic, well, then you'll see it. But you're going to see a lot more if you get down to a lower level at that interface level. So the recommendation is usually to select the interface or interfaces that you need.
All right, great. Thank you, Dan, and thanks for the questions too. Keep them coming. They're good.
Yep.
So Dan, I've gone through all these traces. I want to start my long weekend.
Again,
Um,
keep going.
yeah,
Sorry.
I I'm done. So I need to call TAC.
Okay. Yeah. Sure. And for that, we try to make that easier too. So the idea with TAC, I think, is if you're at that point and you need to collect data, what I would recommend is, when you open the TAC case, go ahead and, send in the data that you can collect using these commands I'm showing here. So this was functionality that was added in 1792 and any version later than that. And it's an easy way to collect all the different serviceability components that we've just reviewed. And you can do that with just a couple commands. And what I would recommend is, open the TAC case and then go and collect the information with these commands, try to recreate the problem, and then put this data right up into the TAC case. It can really help, move the process along and get to root cause faster.
Yeah, also helps with the ping ponging back and forth with the tech engineer asking for more information.
Absolutely. Yeah. Stay a step ahead of it. And that's what these commands were meant to do.
Yeah. Well, thanks, Dan.
Yeah.
Appreciate it. Appreciate the information. Good stuff. Dan Clamert, back to you.
All right. Thank you very much, Dan and Benny. I'm looking at questions. We've got a bunch of great questions here. I think we've answered most of them. There was, let's see here. I think two more. Is there a time limit running the packet capture?
You can set a time limit. For example, if you wanted to do a B trace or a binary trace file, you could say, I'd like to see data from the last 8 hours.
Okay.
If it was a radioactive trace, I'll go back to that CIO example. Your CIO is doing a Teams call, it's intermittently dropping off. You could set up a radioactive trace with just his MAC address, do it at 7 in the morning and let it run the whole day. And then, like I said, if he has that particular issue around noontime, you can go back maybe for a couple hours at 2 o'clock p.m. Tell it to go back a couple hours in time and pull up all the data. So yeah, we definitely have really good timing window configurability there.
And I think the question was related to packet capture. So if that
Yeah,
they're referring to EPC, you can actually limit the duration of the packet capture.
you can, and of course, set up NTP and timestamp should be there. That should be something you could do with the on the Wireshark side.
All right, thanks. One last one here, since we're just about out of time. So this question, and I don't want to open a can of worms here, but it's related to APs and joining the controller. They're having some issues from time to time with APs joining their field WLCs. They say, what tool or how would you recommend we, I guess, troubleshoot this? They said that they're tired of calling TAC each time.
Yeah, I would try the RA trace as a start. So,
Okay.
get the AP or the MAC address of the AP and put it into the RA trace
Mhm.
and just hit the start and let it run. And then when you have issues, go ahead and use the generate button and look back at the traffic for, say, the last 30 minutes or the last hour. That's a start. Uh,
Yeah.
yep.
And of course, syslog is always available.
Yeah.
Yeah.
That's typically going to be once the AP's joined. But yeah, that's a start. See if you can from the monitor page of the controller. I think we will show the AP if it's joined already, but I think there's also a joined option. You can kind of see from that if an AP is trying to join, but something's wrong with the certificate. Maybe something's wrong with the country code. It's a state where the AP is trying to join. It hasn't quite joined yet, so it's not going to show you that it's the first AP, say on the controller, but it'll still show you what the AP is trying to do.
All right. That's great. Thank you very much. So I know just looking at the past history on our YouTube channel Unplugged, there's been a lot of interest around the 9800 content. So thanks a lot, Dan and Benny, for sharing your knowledge on this topic. It is a topic of interest, certainly. And this was another great episode. So thanks a lot. Appreciate you guys coming today.
Yep. Thank you.
Thank you.
And thank you, everyone, for tuning in here. Just a couple last reminders as we close out here. Please complete the survey as we close out. Give us feedback on what you'd like to see in the future. You can always email us too with questions or suggestions for future episodes. You can email us at getunplugged@cisco.com or contact your local account team, your AM or your SE, and they can get a hold of us as well. Until then, thank you again for tuning in. And remember, you can look at future episodes at cs.co/getunplugged. And please go to our YouTube channel, youtube.com/@getunplugged, and subscribe so you'll be notified when we do go live with more great content. All right, until next time, stay connected and unplugged.